Welcome students in the series of Photoelectric Effect. This topic is from the chapter Dual Nature of a Light and for the class 12 physics. This topic is important for the CBSE NEET as well as for the ITJ examination. So let's move with the first topic, which is photoelectric effect. What is the meaning of photoelectric effect? If we are moving on the definition part, so the process of emission of electrons from metal surface when light of suitable frequency falls on the alkali metal. Alkali metal surface is called as photoelectric effect. So, the process of emission of electrons from the metal surface when the light is suitable frequency falls on the alkali metal surface is called as photoelectric effect. Earlier we saw that why we are using alkali metal. If you have not seen that video, go on the video number 1, that is the introduction part of that. So here we have taken an alkali metals and when the particular frequency of a light falling on this metal sheet, the electrons start to eject. This is the incident radiations and this is photoelectrons. And it's alkali metal surface. Still confused? No issue. We are here to clear your doubts. So let us now study photoelectric effect in the detailed version. Consider a metal plate. It has a lots of free electrons. These electrons are random motion. As you can see here, students, electrons are moving randomly in the metal sheet. And which metal we have taken? Yes, alkali metals. These electrons have a tendency to get excited when they receive certain amount of energy. These characteristics of electrons will be studied in this module. Now, according to the Planck's quantum theory, the incident energy is in a discrete form, that is, in packet form, and not in the continuous form. Each photons coming from the same source has same amount of energy, and the energy is given by E is equals to h nu. In a metal surface, there are lots of free electrons, but these electrons cannot come out of the metal surface as it requires certain amount of energy. The minimum amount of energy requires for the emission of photoelectrons is called as a work function W naught. The main point which you have to remember, different metal surfaces have different work function. When the light is incident on a metal surface, it should have a certain amount of energy, which we are called as a work function. So now, moving on the topic work function, if I am just elaborating this topic that what is a work function. So work function of a metal is in the minimum energy required by an electron to just escape from the metal surface. So that overcome the remaining or restraining forces at the surface. So as to overcome the rest training force it is represented generally as a phi naught, or sometimes it is represented as a W naught, which measured in electron volt. So consider a light ray which is incident on a metal plate. When light energy is incident on a metal surface, the electron absorbs the energy. And if light has the same energy as that work function W naught, that is h nu naught is equals to W naught, then there will be emission start to take place of electrons, where nu naught is a threshold frequency. Now we are just moving on the part of electron emission, like what is the meaning of electron emission and why it's happened. So we saw this point, like metal surface of electron absorb the energy, and if light energy have same energy, that means which is equals to the W naught is equals to h nu naught, there will be electron start to emit. This is called as electron emission. So what is the mean of electron emission? The phenomena of emission of electrons from the surface of the metal is called electron emission. The electron emission is from the metal surface is possible if energy possessed by the electron is a more than work function. The required energy of electron for the electron emission from the metal surface can be supplied from the free electron by the following physical process, like a thermionic emission or secondary emission also. So these are the light, and these are the actually photons, which is in the form of light energy, which consisting energy E is equals to h nu. Because of that, electrons start to emit. These electrons are called as photoelectrons, where h nu naught is equals to W naught, photoemission takes place, or in the case of a greater than. So when incident light source has E is a greater than work function, which is equals to h nu naught, then also free electrons absorb the energy incident and then start to emission takes place. And these electrons possess the kinetic energy also. When h nu naught is a greater than work function, that photoelectric emission will takes place and electron will be have possessed the kinetic energy. When incident light has energy E is less than W naught, which is equals to h nu naught, then electrons will absorb this energy, but it being less than W naught. So it will be insufficient for the electron to eject out, and the number of emission will take place. And no emission takes place. So as you can see, if we are sending the light rays, the electrons start to emit. So the first condition for the emission of an electron from the metal surface, when light is incident upon, it is given by energy E is equals to h nu naught, which is a greater than work function. If h nu naught is less than work function, then photoelectric emission will not take place. Now E is equals to h nu. E is directly proportional to, so emission will not take place. When incident light have a frequency which is greater than threshold frequency or the incident frequency, the photoelectrons emission takes place. The minimum frequency of incident radiation at which photoelectrons are ejected from the alkali matter is known as threshold frequency. And the second condition is that nu must be greater than nu naught for the photoelectric emission. Nu is equals to C by lambda. When lambda increases, nu decreases. If nu becomes less, then nu naught, the photoelectron emission will not take place. And the third condition is a lambda is less than a lambda naught. For that, photoemission to take place. These are the three conditions of photoelectric effect. H nu is greater than W naught, nu is greater than nu naught, and lambda is less than lambda naught. If we are just going the detail of work function, so it is defined as the minimum amount of energy of a photon required, which must be incident on a photosensitive material to liberate a photoelectrons from its surface. If I'm just talking about what is a photoelectron, so the electron emitted from the surface of a metal when light of suitable energy above a certain value falls on the surface are called as photoelectrons. Threshold frequency. It is the minimum frequency of incident light required for the emission of photoelectrons from the alkali metal surface. Threshold wavelength also, it is a maximum wavelength lambda naught of incident light ray required to the emission of photoelectrons from the alkali metal surface. Now let's move on to some multiple choice question. The first question is, the minimum amount of energy required for the photo emission to take place is called as threshold frequency nu naught, work function W naught, threshold wavelength lambda naught, or none of these. The correct answer for this question is work function W naught. Next, the minimum value of frequency required for photoelectric emission is called as threshold frequency nu naught, threshold wavelength lambda naught, work function W naught, none of these. The correct answer for this question is threshold frequency nu naught. Third, the maximum value of wavelength required for photo emission to take place is known as threshold frequency nu naught, work function W naught, threshold wavelength lambda naught, or none of these. The correct answer for this question is threshold wavelength lambda naught. Fourth question we have, the condition for photoelectric effect to take place are h nu naught is greater than or equals to W naught, nu naught is greater than or equals to nu naught, lambda is less than or equals to lambda naught, or all of these. The correct answer for this question is all of these. Now, the experimental study of photoelectric effect from the construction to the working we will study here. Construction. The Hertz experiment arranged for photoelectric effect is as shown. It consists of an evacuated glass tube which has a quartz window W. What is the meaning of a quartz? Quartz is a silicate crystal mineral which is found under the earth continental crust. Why do we prefer quartz window? It is made up of quartz because it allows only UV rays to enter the tube and the photosensitive only entertains UV rays. So I think you understood, students, why we are using quartz. It's because of quartz is a particular material or a metal which is only allows to UV rays to pass through it. This glass tube consists of a photosensitive plates known as E. So that is a cathode or emitter, and the metal plate is known as anode and collector. So E and C, these are two plates, electrodes and collector. At the instant photosensitive plate E has a negative charge and metal plate C has a positive charge. It consists a reversing key known as a commutator key, which is used to maintain the collector plate C at desired positive and negative potential. It's known as a commutator. It consists of a voltmeter V, which is used to measure the potential difference, and micrometer is showing in a microampere to measure the photoelectric current, which is an IP. It consists a rheostat also, which is used to vary the potential difference between the plate. It consists a battery, which is used to supply or apply the potential difference between the plates. So it is a complete infrastructure of this device. Now how it will be worked? So this we will see in the working zone. Consider a monochromatic source of a light S with energy h nu naught, which is greater than W naught, is incident on a quartz window, passing through which is incident of a photosensitive plates E. The photosensitive plate E will emit electron, which will be collected by the collector. Due to this, electric field will be generated and induced current produced. This is called as photoelectric current. So what is a photoelectric current? The current which flow in the some external closed circuit due to the flow of photoelectrons in that circuit is called as photoelectric current IP. The photoelectric current IP will be measured by the microammeter, which is a mu A, and potential difference is measured by voltmeter. Now we will study the variation in photoelectric current IP with respect to time. So these are main causes which can did the variation: frequency of incident radiation, intensity of incident radiation, potential difference between the plates, the nature of the material which we have taken of the plating. Now let's take some MCQ questions. The first question is, the incident light wavelength are shorter, longer, both shorter and longer, none of these. The correct answer is shorter. The current included in the photoelectric effect is known as photoelectric current IP, electric current I, magnetic current, or none of these. The correct answer for this question is photoelectric current IP. Now, experimental study of photoelectric effect by frequency graphs. So, effect of frequency of photoelectric current IP is a suitable potential difference is applied between the plates with C at the positive potential. Incident light has constant intensity and frequency is varying. There is no emission of photoelectrons till the variation of frequency given as E is equals to h nu. So nu must be greater than nu naught and h nu is greater than work function. As V naught is reached, photoemission takes place and photoelectric current IP begins to flow, and it flows constantly. Now we will study the graph between the frequency and photoelectric current. When nu is less than nu naught, no photo emission takes place. When nu is greater than nu naught, photoelectric emission takes place and photoelectric current obtained. As you can see, IP is equals to constant and the graph will be ideal graph. Where IP is a constant, this is a practical graph. So what is the conclusion of these two things? Photoelectrons are emitted from a given surface only if nu is greater than nu naught. Now let's move with some questions. The wavelength of incident light is shorter, longer, both shorter and longer, none of these. The correct answer for this question is shorter. The current included, the photoelectric current effect, is known as photoelectric current, electric current I, magnetic current, none of these. The correct answer for this question is photoelectric current. Experiment study by the photoelectric effect intensity graph. So let nu is greater than nu naught, where nu is a constant and intensity increases, collector plate is maintained at positive plate with respect to the emitter plate. When intensity of a light increases, that is, the number of photons striking the metal plate increases, and number of electrons increases, and photoelectric current IP increases. As you can see from this. So it's a graph. Now we will study the graph between intensity I and photoelectric current IP. When intensity increases, photoelectric current IP increases, given that nu is greater than or equals to nu naught. So when intensity increases, photoelectric current increases. That means I is directly proportional to the I. Now move some MCQ question. When intensity increases, photoelectric current increases, decreases, it constant, none of these. The correct answer for this question is increases. When intensity of a light increases, kinetic energy increases, none of photons increases, both A and B, and none of these. The correct answer for this question is none. Number of photons increases. Now experimental study of photoelectric effect, that means potential difference graph. Effect of potential difference on photoelectric current IP. Now firstly consider a plate. Which plate? Metal plate. Metal plate has a lot of free electrons. Light is incident upon it from the source S having nu is greater than nu naught. A photon can be penetrate up 10 to the power minus 5 area of the metal. And here the area is 10 to the power 5. When light falls on the metal surface, the electron present at the top absorb that energy and eject itself out. The remaining energy left after the ejection is called as the kinetic energy. But what about the electrons in the bottom layers? The bottom layers. The electron is in the bottom layer first absorb the energy and use of that energy comes up and then eject electron out, and after this remaining energy is kinetic energy. The kinetic energy for electrons is the bottom layer is kinetic energy is equals to h nu naught minus w naught. So kinetic energy for electrons can be from 0 to kinetic energy maximum, and each electrons have different kinetic energy. Electron possessing kinetic energy travels towards the collector and get collectors at the collector photoelectric current IP is obtained and goes on the increasing as number of emitted electrons decreases. At some point for certain potential of the plate C, at the emitted electrons are collected from the plate C. After this photoelectric current does not increases as all electrons are collected by plate C. This current is a maximum and its value is called as saturation current or photoelectric effect current. We will change the polarity of the plate C with respect to E. Plate E becomes positive and C becomes negative. When light is incident on a plate E, the electrons are emitted and all electrons are travel towards the plate C, as you can see in this diagram also. Now the negative potential is the plate C is gradually increases. As the negative potential increases, work done by the plate C and given by work W is equals to Q. Work done by the electrodes W is equals to electron volt. Charge is negative for electrons. It is the increases till it equals to kinetic energy. Kinetic energy is equals to EV naught. For kinetic energy, maximum potential should be maximum and it is known as stopping potential nu naught. The minimum negative potential Vs given to the metal plate C, for which photoelectrons or photocurrents stop and becomes more, is 0. That is called as stopping potential. Now negative potential increases till the equals to the kinetic energy maximum, and kinetic energy maximum is equals to E. Once this achieve, the photoelectric current slowly reduces to the 0. How does this happen? If the electron processing maximum kinetic energy are stopped by Vs, then it is obvious that all electrons coming after the electron processing kinetic energy maximum will not be allowed to reach the collector plate C. That is, negative plate C repels electron and it does not allow it to reach to the plate C. The phenomena of electric current IP will be reduced to 0. Let us see the graph between stopping potential and photoelectric current. So it is the graph between stopping potential V and photoelectric current IP. We see from this experiment that when positive potential is reduced to 0, the photoelectric current decreases. However, the potential difference between the plates is 0. Photoelectrons are still reaching plate C. Photoelectric current is still obtained. Now when polarizing plates or polarides are changed, the potential of the plate C becomes positive and the negative potential is increased gradually till becomes 0. In this situation, the graph we will get a saturation graph or saturation current graph. Now let's move on to some questions. The minimum negative potential Vs is given to the plate C for which photoelectric current stops is called as stopping potential, negative potential, positive potential, or none of these. The correct answer for this question is stopping potential. Next question. When positive potential of plate C is reduced, photoelectric current increases, decreases, constant, or none of these. The correct answer for this question is decreases. Now, we move on the topic Einstein photoelectric equation for photoelectric effect. In 1900, Max Planck comes with the theory of a light that light energy travels in the form of discrete packet which is known as quanta or photon. A light energy traveling with an energy which is E is equals to h nu, where h is equals to Planck constant and every packet has some same amount of energy. But in 1905, Einstein extended the idea of Planck and that light energy travels in the form of discrete packet of photon they tell, which explain the characteristics of photoelectric effect and more satisfactorily. Now first let us see the assumption made by Einstein. He made the three assumptions. First, an incident light radiation of frequency nu consists steam discrete photons and energy is h nu of photons. Third, the photon moves through the space with the speed of a light which is 3 × 10⁸ meter per second. When light of frequency nu is incident on a photon surface, there are collision between the photons and the electrons occur. Now let us study the Einstein photoelectric equation. Consider a photosensitive plate. Metal surface consists the number of free electrons. Consider a light incident on this metal plate which is in the form of photon consisting energy h nu. When this energy falls on the metal surface, collision takes place between the electrons in the atom or photons. During such collision, entire energy of the photon is transferred to the electron without any time lag. The minimum energy required to eject free electrons from the given surface is called as photoelectric work function W0 of the material of the surface. The absorbed energy h nu electrons from the incident photon is used in two ways. First, a part of energy is used by the electrons in liberating itself from the atom. Second, the remaining energy h nu naught minus W naught appears as a kinetic energy in the form of electrons. If electrons does not lose any energy, any part of this energy in the collision inside the surface and escapes with the maximum kinetic energy, which is the half mv square max is equals to h nu minus work function W naught, where m is the mass of electron and v is the maximum velocity of electrons. We know that kinetic energy maximum is equals to EVS, where Vs is equals to stopping potential. Half mv square maximum is equals to EV naught. EV naught is equals to h nu minus W naught. The photoelectric effect equation which is given by Einstein are this: kinetic energy maximum is equals to h nu naught minus W naught, or we can say half mv square is equals to h nu minus work function W naught. Second equation, EVS is equals to h nu naught minus work function. Now, explanation for the characteristics of the photoelectric effect with Einstein photoelectric equation. Characteristics of photoelectric effect are: first, to take place photoelectric emission, the incident light must have frequency nu is greater than nu naught. If it has So nu is less than nu naught, then photoelectric emission or photoemission will not take place. Second, for the given photosensitive metal and incident radiant, nu is greater than nu naught and IP is proportional to I. Third, for a given frequency nu naught is greater than nu naught, the maximum kinetic energy linearly increases with increase in frequency. It is independent of the intensity. The photoelectric effect is an instantaneous process. There is no time lag. According to the Einstein photoelectric equation, energy of photon is equals to photoelectric work function plus kinetic energy maximum, which is h nu is equals to work function W naught plus kinetic energy maximum. And it gives h nu naught plus kinetic energy maximum. So h nu minus h nu naught is equals to kinetic energy maximum, and kinetic energy maximum is h nu minus nu naught. If nu is equals to nu naught, kinetic energy is equals to 0. According to the Einstein photoelectric equation, h nu minus nu naught is equals to kinetic energy. When nu is greater than nu naught, then kinetic energy becomes negative. We all know about kinetic energy cannot negative. So when nu is greater than less than nu naught, no photoelectric emission takes place. When nu is greater than nu naught, kinetic energy has some positive value. So photoelectric emission takes place with the positive value of a kinetic energy. According to the Einstein equation, we come to conclusion that when nu is equals to nu naught, the photoelectron are emitted without kinetic energy. Less than nu naught, photoelectrons are not emitted. Greater than nu naught, the photoelectrons or photoelectric electrons are emitted with some kinetic energy. According to the Einstein photoelectric equation, h nu minus nu naught is equals to kinetic energy maximum. As the intensity increases, the number of photons striking the metal plate increases. As the number of photons increases, the photoelectric current IP increases. This explains that IP increases with increase in intensity. Emission of photoelectrons is a result of collision between the electrons and photons. The photoelectric effect is an instantaneous and there is no time lag process. Now let's move with the questions part. If nu is less than nu naught, will photoelectrons be emitted? Yes, no, maybe none of these. The correct answer for this question is no. If nu is less than nu naught, the kinetic energy of emitted electrons will be maximum, minimum, 0 or none of these. The correct answer is 0. If increase in the intensity of beam will dash the photoelectric current. Increase, decrease, no changes, none of these. The correct answer for this question is increases. Next, maximum kinetic energy of emitted photoelectrons depends upon frequency, intensity, wavelength, or none of these. The correct answer for this question is frequency. Student, this is all about for the today's class. I hope you like the session. Take care of yourself. Till that, thank you everyone.